Greetings, salutations. It's time for another episode of Young Earth Creationist Flood Geology Failures. We're going to talk a little fossilized caves. Think about fossilized caves. What's a fossilized cave? Well, that's my word for a cave system which has been completely filled with sediments which themselves have turned to stone. And so we have a fossil of a cave system. This came to my attention as I dug into a recent Institute for Creation research article about fossilized skin. Let's do it. Let's dig into it. Flood geology failures, fossilized caves. We've got that coming up next. So what got me thinking about fossilized caves or ancient cave systems? A cave system you can't walk into because the entire cave is full of rock. How do we identify what an ancient cave system is, a preserved cave system? More importantly, what are the things we find in those rocks that have filled in those caves? Well, we find fossils. And there's a particular cave system in Oklahoma which has some spectacular fossils, spectacular sets of preserved specimens, including preserved skin samples. So that's what brings us to our Institute for Creation research article. Fossilized reptile skin is still reptile skin. Now, what a title. Fossilized reptile skin. Oh, it's still reptile skin. Now, you could take that one way. That is that the reptile skin, even millions of years later after preservation, is still reptile skin. Well, except it's not actually reptile skin since it has been replaced by minerals, and it's an impression of the skin, or been completely permineralized, or in this case, been turned into, in some cases, pyrite. And so it's not actually reptile skin. It's the former remains or representation of what was there at one time. But that's not actually what they mean by fossilized reptile skin is still reptile skin. So let's check it out. Skin is the largest organ of your body. It helps maintain a person's or animal's homeostasis, insulation, and sensory functions. As such, it is very complex. Now, this next sentence was a doozy. Maybe you can help me figure it out. Creation scientists predict, here's a prediction of creation science, that whenever skin is found in the fossil record, it will be 100% skin, unique and functional to that particular animal group, You got that? That's a prediction of creation science. Whenever you find skin, it'll be skin, and that skin will be unique and functional to whatever animal group that skin came from. Quite the dramatic prediction we have here, and apparent fulfillment in this particular fossil. Oh yeah, this next sentence gives us the main characters in our little play here of this week's episode of Flood Geology Failures. There's a tiny amniote that's been found, which is a type of terrestrial vertebrate. That would be all terrestrial vertebrates are amniotes except for the amphibians. And what was found? Some epidermal skin. So remnants of skin of these amniotic organisms. And where were they discovered? They were discovered in an infilled cave system in Richard Spur, Oklahoma. So now here in the ICR article, he mentions that this was found inside an infilled cave system. This is the first record of a skin cast fossil from the Paleozoic era and is the earliest known occurrence of epidermal integumentary structures. Here we also report on several compression fossils, right, carbonized skinned impressions, all demonstrating similar external morphologies to extant or living crocodiles. In other words, another reptile. Now, for a young Earth creationist, how would they account for this skin preservation? Well, clearly it's a global flood, right? That's your go-to explanation for most of the fossil record, including anything like these soft tissue preservations or soft indications of soft tissue's presence in the past. The first author of the current biology paper, Ethan Mooney said, animals would have fallen into this cave system during the early Permian and been buried in very fine clay sediments that delayed the decay process. Right? So here they're admitting, he's saying that here's what the author says, right? There's animals maybe living on the surface of living at some point in time, the surface of the land. and there's a crack or a hole or a pitfall cave, right? So you have a cave underneath the ground, and animals fall down into there, basically falling to their death, and then they get preserved inside this cave. And the cave is filling up, with material that's falling in. Now, what would be the creationist explanation for this? So here's Frank Sherman's explanation. All right, here, and we're going to begin with the flood geology failure here. Creationists, on the other, maintain these animals were killed and buried in fine clay sediments laid down by the flood about 4,500 years ago. So there you go. There's your blanket statement. They were simply preserved by a global flood that killed these animals and buried them in fine clay sediments. That in itself, how the flood, a chaotic worldwide event laying down thousands of feet of sediment, can lay down clay layers. That's going to be a whole nother episode in the coming months. We're going to talk about the production of clay in the fossil record. All right, so let's save that. But in this case, he's saying that this is just, hey, well, they were just floating around. They got trapped in this sediment and they got preserved. Great. So we have to pull out, in order to talk about the cave, we have to pull out one other thing that Frank Sherman is going to make note in the ICR article. He's going to talk about, like, how in the world could this get preserved? How would skin get preserved? So he quotes from the Cell Press article. The Cell Press article is a popular press version of the original paper. We're going to go look at the original paper. Skin and other soft tissues are rarely fossilized. Yep. But the researchers think that skin preservation was possible in this case because of the cave system's unique features, which included fine clay sediments that slowed decomposition, oil seepage, and a cave environment that was likely an oxygenless environment, right? Those three things combined, they think, created this special preservation situation, which gave us these really amazing skin impressions or preservation of skin. Now, Frank Sherman's going to go all into a big discussion about microorganisms. He's going to quote some other creationist journals showing how, hey, oil is actually eaten by some bacteria, and therefore, how could that oil have been present for a long period of time to be able to preserve these specimens? Since we know that oil can be eaten. Of course, there's billions of barrels of oil on the earth, and it's not obviously all being eaten up right now by microorganisms. That in itself requires some very specialized conditions. But let's get to the paper. Well, we just got to get to this. This is just to help us get to the original article. Paleozoic cave system preserves oldest known evidence of amniote skin in current biology. And they summarize their work like this: the richest and most diverse assemblage of early terrestrial pteropods. Early terrestrial pteropods, right? Pteropods, things that walk on four legs. So vertebrates that are walking on land, and the earliest assemblage. I mean, some of the most, well, in evolutionary terminology, some of the most primitive or like the ancestral versions of tetrapods are found in this infilled cave system in Richard Spurs, Oklahoma. So, which has been dated to the cave system, the infilling of the cave system dated to 289 to 286 million years ago. I have to say the infilling because the actual rock that the cave is in would be older than that, right? The stuff that fills in the cave later on, right, that's going to be a much younger age. So the rock itself, the limestone itself that makes up the original the limestone itself, right, for which the cave has eroded, is much, much older than that. Some of the oldest known terrestrial amniotes are exquisitely preserved here because of the early impregnation and encasement of organic material by oil seep hydrocarbons within rapid deposited clay-rich cave sediments under toxic anoxic conditions. So they think this was a cave system that had, cracks in the earth that were developed into this cave. There was maybe water at the bottom of this cave that was anoxic, lack of oxygen. Sediments are being come from above, right, from erosion. And that will include bits and pieces of bones from animals that have died on the surface, or potentially, and they actually have evidence of both in this particular cave, because they have disarticulated and articulated skeletons. So skeletons are just pieces, random pieces. And then they have like skeletons that are like whole preserved animals. preserved in this particular cave. So the either animal fell into the cave, got trapped down inside of there and died, or it died on the surface, and then parts of that animal ended up in that cave in the sediments that were deposited there. In this oily, seepage, hydrocarbony zone with no oxygen. All right, all that led to remarkable preservation. This phenomena has also afforded the preservation of exceedingly rare integumentary soft tissues. Reported here, providing critical first evidence into the anatomical changes marking the transition from aquatic and semi-aquatic lifestyles of amniotes, that would be amphibians, right, which really are bound very much to very wet environments, to organisms that like reptiles, right, and other synapsids, other things that lived in much drier habitats, and that's going to require differences or changes in their skin for protection from the environmental influences. This is the first record of a skin cast fossil, which includes 3D carbonization of the skin proper from the Paleozoic era and the earliest known occurrence of epidermal integumentary structures. We also report several compression fossils and so on. All right, so let's, we don't need to look at the rest of that. You want to see the pictures. So here are the images of some of these skin impressions or actual preservation of 3D anatomical structures of the skin. I want to say, this doesn't mean this is the actual original skin that's preserved. It's the original shape of the surface texture of the skin. And then the actual tissues themselves have been replaced by other molecules. So you see all these little interesting design. And these are actually from several different types of organisms. So showing different features, and they all kind of have this scaly appearance. So much like some modern reptiles, like alligators. Oh, by the way, notice the size there, 1 millimeter. So these are very, very, very tiny little fragments. So you're seeing very close up, very, very small impressions on the surface. And here we have these are all images from that paper that I mentioned. Here you have, they've done a 3D cross section of the skin. And so you see that, and you're very close up, 50 micrometers. And so you don't really see like individual cells, all right, in this. You see just the remains of the overall shape of the skin itself that's left. But that's not complex organic molecules that you have here that representing the original molecule, like the original organic molecules left in the skin. This is mostly inorganic material that's been replaced with, so hence we call it a fossil. And then we have something that looks a little more scaly-like on the surface of some other animals that are found preserved in this area. And here is a very, very tiny skull of a small reptile. And they're showing in these little blue bars down here, these are remnants of these little like scale-like features that are preserved for us. Right, so that's the kind of preservation we're talking about with these particular fossils that are found in this cave system. But we want to talk about this cave system because that, to me, is the real failure that flood geology experiences here. It's very difficult to imagine how a global flood produces a cave inside a layer of sediments. All right, so you have to have a layer of limestone laid down. Then you had to have the limestone be eroded to form a cave formation. And then after the cave formation forms, you have to then have sediment fill that particular cave. Then that sediment has to turn to rock. All right, meanwhile, you have other layers of sediment on top of that, which then erode to form the modern surface of Oklahoma today. So what I did is I went to look at more about the actual cave itself. And so I found this paper in Paleogeography, Paleoclimatology, and Paleoecology from 2017. So Mark McDougall and colleagues, the unique preservational environments of the early Permian, fossiliferous cave deposits of the Richard Spur locality in Oklahoma. And what they have in there is this figure, which I had on the cover slide for this talk. And so what this is this is a 2D rendering of basically where the cave deposits are versus all the white area around it, which is all limestone. So like one really thick limestone block. All right, and what I don't have in here is a scale, but this is about 20 meters high. So this is 60 feet. So this is a fairly, and this is just a small section of the cave. What is it? This is a quarry. All right, it's a limestone quarry, and they have, dug way down into the earth in Oklahoma to quarry out limestone. And as they're doing so, they realize that not everything in this block of limestone is limestone. What they find is there's a whole bunch of siltstone and mudstone, all right, and claystone, right, which are sedimentary rocks. And those form little layers, right, which are in these grayed out areas in this figure here. And so in the middle of a block of limestone, they run into, and well, what this is, what you're looking at is a cross section of a wall. They've cut a huge segment, down into the earth, and up against that wall, then you can actually see that it's not all limestone. You can see these what look to be cracks, fairly large cracks, right, that go deep down into the limestone, and they're just filled with this claystone and siltstone, right, mudstone, right, various sedimentary rocks, which are very different than limestone. And so they're not interested in this particular rock. They're interested in the limestone. So when they come across this, they have to dig all this material out, right? As they break the wall, they're taking all these chunks out of these other rocks, and they put them on the spill pile, all right, the spoil pile. And there, somebody has noticed that there's a lot of fossils in those. There's really no fossils in the limestone itself. It's a pretty homogeneous unit. But in what looks to be what had been crevices or a cave that was in the limestone, had dissolved out the limestone and formed a cave. What filled the cave was a bunch of sedimentary rock that's full of fossils. Right? So you can think of the gray area as like lots of fossils in here, the white area, no fossils. And oh, by the way, what's at the top is just the current surface in Oklahoma. All right, so let me just show you real quick some of the fossils there. I mean, exquisite preservation of tiny little reptiles and other amniotes, and amniotes, meaning not amniotes, which means amphibians. You see this 1 centimeter, right? 1 centimeter. So this is a very tiny organism, but you can see amazing preservation. Some of these organisms are preserved in calcite, and so that's like a crystallized, that's a crystal that would form on the surface of the bones as it sits in water. So like water that's highly concentrated in various minerals. And then you have this crystallization forming around the bones. Now that's only going to happen when you have water, all right, basically mostly very still water with not a lot of other sediments in it, forming around these fossils. So many of these fossils are pyritized. So you have a lot of sulfur production from the breakdown of the organic remains of these organisms, along with a low oxygen environment, entices the production of pyrite. And those pyrite crystals then form on the surface of the bones. So you have these pyritized, sort of goldish looking fossils. Here's another really neat thing about this particular cave. So because of the amazing preservation and the amount of material that's come out, because basically what's happened is in the quarry, they've essentially quarried out all the contents of the cave, right? The whole cave was completely filled in long ago. They've taken out all that infilled stuff and put it in a big pile, and we've been able to look through it and find all these fossils. And then we've identified the types of organisms that are in there. And here's a list of all the fauna, right? All the animals so far that have been found. Lots of other stuff's been found, but these are the animals. These are just the tetrapod animals. Reptiles, and so here's a bunch of different reptiles. And then you have synapsids, right? Synapsids are these weird animals that are reptile-like, but they have mammalian sort of type features to them too, and they're considered to be the ancestors of mammals. Not reptiles are not considered the ancestors of mammals. And so there are some synapsids, which are a completely extinct group of organisms today. And whoops. And then you have the amniotic tetrapods. So these are all amphibians. And every single one of these things mentioned here, these are all extinct organisms. So that's what's found. That's what's been found through many, many, many studies of these rocks. Reptiles, synapsids, and amphibians. Interesting pattern, huh? There's no other, well, there's a very limited number of reptiles. These reptiles all, by the way, look kind of, I'll say kind of lizard-like, right? But the ancestors of all reptiles seem to have been considered to be like kind of like amphibians, right? So we don't have like dinosaurs. We're not talking those kind of things. There's no snakes. There's no dinosaurs. None of those type of what we consider advanced reptiles or things found higher up the fossil record. We're way down the Permian. We're before the dinosaur age, right? The age of the reptiles. Let's stop and let's think about it for a moment from a young Earth creationist perspective. This flood, how do these animals get preserved? Well, we saw up here. Creationists, on the other hand, maintain these animals were killed and buried in fine sediments laid down by the flood. Right? A simplistic explanation. Oh, it's simple. These animals were wandering around, they got caught up in a flood, and they got preserved. But then let's think about the community of organisms that are found here. The community of organisms found here are only extinct reptiles, synapsids, and amphibians, and a lot of different kinds. So imagine this one little spot, right? Just covering a couple acres of land. This one spot happened to have 40 different species of these types of organisms, and yet didn't have no birds, no mammals of any type, and most every type of reptile not present here. Weird. Weird that they would, like, how would a flood select out such an odd assemblage, actually fairly consistent assemblage of rather similar like organisms, all here in the same spot. And they all get preserved in sediments that are inside of limestone, a limestone infilled cave. Now, our author, Frank Sherwin, he mentions that this is an infilled cave, but then immediately just goes to like, oh, this just happened during a flood. I'm going to say it again. I mean, there's tens of thousands, if not hundreds of thousands of little pieces of organisms that just fill these sediments. And so this does look like a pitfall trap. Pitfall trap is where you have like, typically kind of a flat surface, all right? And then there's a hole in the ground, and that's because there's a cave underneath, right? And a little bit of the ceiling fell out. And so there's a hole that falls into this cave and you really can't get out. So animals might be running across, trying to escape a carnivore, and then they fall into the hole, right? Fall to their deaths, and their bones just pile up. There's many places in the world where we have these giant bone piles inside of these cave systems. And so this looks like a giant pitfall cavern system in which everything that fills in this cavern system are just tons and tons of pieces of bones. But the thing is, most of them aren't articulated, right? Most of them aren't part of whole organisms, right? So it does appear that maybe they were also like organisms on the surface that then have died, and their bones have become separated, and then they get washed into this hole and they fill up this particular cave. Now that doesn't work with the global flood, right? The global flood, we're saying like, hey, here's a layer of mudstone, right, at the bottom of this cave, except it's not a cave. It's just like the world is covered and these things just get preserved. So going back to, we got a whole bunch of different species, all found within this particular layer of rock in the Permian, except that it's a block of limestone, which doesn't contain fossils. So how is the limestone formed during the flood? How is a thick layer of limestone formed in the flood with very few to no fossils in it? But then within the limestone, there appears to be a cavernous system. Well, how do you get a cave? You have to dissolve the limestone. How do you dissolve the limestone when it has to be formed during the flood? Because, you know what? Let's get my pen out here. Terrible with the pen, but let's give it a try. Let's say we've got some layers of sediment, because there's a bunch of layers of rock, thousands of feet of rock below this limestone, right? Below this limestone. I shouldn't say thousands. I haven't looked that up. Let's just say there's just 500 feet. I'm sure there's at least that much of sediment below this limestone layer, right? And then you have a big block of limestone. This is what they're coring, to get giant limestone blocks that they want to be consistently limestone, right? And you have all that limestone. And then so that has to be laid down, right? The layers below have to be laid down during the initial stages of the flood. And then somehow you lay down limestone, but that itself is a problem in terms of explaining the existence of consistent thick layers of limestone in the middle of a flood covering the whole world. How do you get that limestone? But even if you said you got the limestone, how did you get a cave inside the limestone? You can't make the cave at the same time you're making the limestone, right? You're going to have to make the limestone as a rock, right? Then you're going to have to dissolve some of that limestone. So then you have the formation of caves, right, inside of there. You know, maybe the limestone cracks, you have a crack in there, water seeps in, and you begin to widen that crack over time. But anyway, you end up with a cavern system inside of that limestone. You have other rock on top of the limestone, so other sediments are laid down on top of the limestone, maybe at the same time as the caves are forming later on. But this would still have to be, you know, you don't develop the cave unless it's above water, right? Water has to seep and flow through there. And then you have a point in which you have an opening to the surface. Then you have organisms out here, and then they're falling down into this cave system or getting washed down into the cave system. Eventually, the cave system forms a whole bunch of layers of sediments. And the thing is, inside the cave, there are distinct layers of sediments, right? There's mudstones and claystones, right? And siltstones, which represent different sediments, representing different energy, amounts of energy of deposits. So if this is all part of a worldwide flood, how do you get discrete layers within the flood? I mean, within the caves, inside of another layer of the flood. And then these all have fossils in them, but then look over here. They are a particular type of fossil, right? We don't have any mammals around. We don't have any dinosaurs around. We don't have any birds around. We don't have most other types of reptiles around. It's a very select group, but a fairly diverse group of synapsids and early reptiles and amphibians. And they're all found in great abundance, tens and thousands of these things. How does a flood sort? After you've already laid down hundreds and hundreds of feet of sediments, how do you sort out to be sure that you have like this collection of animals to put into this particular cave? I don't know. I'm struggling to even put this into words, just how fantastic the series of events have to be within a young Earth creationist perspective to explain particular locations like this. I really think Frank Sherwin never really even thought about this, right? He provides no explanation. He mentions Infilled cave simply because I think that the original paper says, oh, these were thought to have been an infilled cave. And he just, well, you know, that can't be. It's got to be a flood. You know, and eventually the entire thing gets completely filled up. And all of this then turns into stone itself, right? More layers are laid down at some later point in time, right? Like during the actual reptile age. So there's other fossils in these layers above. Now, in Oklahoma, these layers aren't found at this exact location because the surface is like right here, not very high above that limestone. But if you go a little farther away in Oklahoma, there are other places where there are higher layer, you know, there are more layers in other rocks, right? So we know that that whole area was covered with more layers of rocks at one point. And so all of those would all have to have been stripped away, right? You have to erode all of this. You get down to this point where you're down to where the limestone is near the surface, and that's why there's a quarry there, right? Because you didn't have to dig way down to get to the limestone. The limestone's like now it's at the surface, even though it's this, even though the infilled stuff is Permian age, the rest of it's even older than that. This is really old rock, and now now you've quarried out all this stuff, and that's where these fossils are. All right, I'm stumbling over my words today. I hope you get the gist of this, the gist of the flood geology failure to explain infilled caves. What is the origin of caves within the biblical flood layers? And then why a certain select organisms inside the filled in caves themselves? How did the caves get filled in with these substances, with these things? How did just these particular organisms get there? Yeah, this one really left me scratching my head, from a young Earth creationist perspective. I can't wrap my head around how you'd begin to explain these types of cave systems. And this isn't like a one-off thing. There are many, many, many places in the geological column where we identified sediments, right? Rocks that are inside of caverns, or inside of what previously had been caverns in another form of rock, right? In other words, caves. There were caves in the past, and those caves are filled. Just like you can go to modern caves today, and even if you can go in the cave, there's large segments of the cave that may be filled with sediments. And eventually some of those caves will be completely filled with sediments. And then if erosion covers that whole cave system up, there's not going to be any cave there anymore. It's going to be just a fossil cave, right? The remnants of a previous cave, just like fossilized organisms are remnants of an organism that had previously been there. There are some very famous fossil hominid sites in South Africa that are essentially come from old caves that are completely filled up. And what they're doing is they're looking at the material that's in that cave. So those caves, the rock inside of there is all cemented together inside those original caves. And that's where they're finding really interesting fossils. All of those, I think, are really big challenges to young Earth creationist flood geology. Okay, that's enough. I mean, I'm tempted to try to explain all that again in simpler terms because I probably used way too many terms to explain that before, but nah, that's too much. This is good enough. Talk to you later. See you next time. Bye-bye.